my name is Jacob Savoy. I work with USGS at their Aero Center, which is kind of their big data hub for Landsat, LPDAC, kind of aerial imagery. So I'm mostly working in the raster world. I know a lot of you guys work in the vector world, but you can pull raster data in and trying to show some benefits of if you were to do that, some of the things you could do with the Landsat data. So don't know how familiar all of you are with, so I put a kind of introduction slide. So Landsat is actually the longest Earth image acquisition program. We launched Landsat 1 in 1972 and launched Landsat 9 very recently. Currently 7, 8, and 9 are all operating. So we actually have 3 satellites imaging. The spatial resolution since Landsat 4.5, we've gathered in 30 meter by 30 meter pixels. And each of the scenes, is what we call them, covers about 180 by about 185 square kilometers. We do have a panchromatic band that does cover 15 meters by 15 meters per pixel. So it's a little bit increased resolution, and you can use that to what we call pan sharpen. So it increases the resolution of the what you would natively get at 30 by 30, but that is an option. Spectral resolution, 8 and 9, again, which are the big ones operating right now, offer 11 wavelength bands that includes 2 thermal bands, as well as, again, the panchromatic band that you can use pan sharpen. And the temporal resolution, 8 and 9 are operating opposite each other right now. So normally a 16-day repeat cycle to get the majority of all land surface on Earth is reduced to a 8-day revisit cycle. So Landsat 8 will get it, and then 8 days later, Landsat 9 will get it. So what are some use cases that you might use OSM data as well as Landsat? Time series. Again, Landsat data, we've got more than 50 years of data. So I know OSM, what you're looking at is a current day map of what's there, but you can kind of look at historical Landsat data to be able to determine how it grew to the point it is now. Land use, land cover change. I know a lot of the layers in OSM, the parks layers, the water layers, and you can see how it changes historically with Landsat data if you were to overlay that onto the OpenStreetMap. We also have urban expansion. Again, historical record, that's the big thing Landsat's good at. You can look at not just urban areas, but forested areas, deserts, seas, that kind of thing. We do also offer nighttime imagery. That's not super well known. Normally, because the 8 and 9 satellites currently have a visual sensor as well as a thermal sensor. You can get thermal data with that. So even if it's pitch black out, you're still going to get some imagery that you can see that is useful for mapping oil wells, gas wells, city lights, that kind of things. And then a big one that I saw was a segmented shoreline. So if you're looking at a large area and your water polygons especially, as tides move in and out, as things dry out or swell up, you can use Landsat imagery to update those. And then I split this one out a little bit, didn't intend it this way. I don't know how many of you saw Jeremy's presentation to plenary this morning. I kind of wanted to do a quick walkthrough of urban heat studies. This is demonstration. It's not a study at all, but it's to kind of show and highlight kind of pulling that heat data out so you can actually pull it into a program with OSM data. And rather than just seeing areas, you can take a look and go, hey, something's up with that building. It's got a very high temperature. So I'm going to walk through that kind of quick here. So I put the ID of the scene we're looking at. If you want to follow along, if you want to replicate this, easy way to find it. On the left, we have our band 10. That's going to be one of our thermal bands. And then on the right, we've got a natural color image. This is over Richmond. So that's kind of where I focused because of the conference. And again, the natural color is going to be our bands 4, 3, 2, and that's going to show a green is green, red is red kind of thing. This image in particular was gathered last year about this time, June 17th. at 1546 GMT, which translates to just before noon local time. On that day, I went and looked at weather underground and was able to pull air temperature data from the Richmond airport. So on that day, it was 93 degrees out. Keep that in mind. This is our surface temperature product. Obviously, water is blue, it's cool. In the city, it's hot. However, keeping in mind that 93-degree air temperature, we saw temperatures as high as 165 degrees in Richmond on that day. Tried to classify this. A lot of it is going to be, the graph is a chart of kind of where the pixels fall and what the values are. So you can see the majority of pixels are between 75 degrees and 130 degrees. Again, 130 degrees is hot, but it's not 165 degrees. And so you can see kind of in the upper right-hand corner, it's in the water. It's probably pretty deep there. It's going to be a little cooler. And then the big 130 to 165, there's just a few of those pixels. You're not really going to see them. So what I did was pull them out. On the picture of Richmond here, every little circle there you see in red is an area that got between 130 and 165 degrees. However, at that scale, don't know how useful it is. I've never been to Richmond. It's my first time. I don't know where these are. And even zooming in on them, again, I haven't been here. I don't know what that is. I couldn't tell you what that is. I know it's hot. And so pulling that data, and again, it was a pretty simple, like 10-minute process to get from that raw thermal band to this information right here. We can see, not judging, not saying anything about these locations, but I can point to that specific cross street and say, hey, something's going on here that's causing a between 130 and 165 degree heat spike. If I'm looking at urban heat studies, maybe that's a place I go and investigate. Let's talk to them, get them to change their roof, maybe bust up the concrete, maybe whatever it is that is contributing to that, you can see exactly where it is and begin focusing on those areas. So we don't just have heat data, we've got all these different kinds of data. The real time is published basically a couple hours after the acquisition time is. And again, 8 days, you're getting imagery just as fast as you could possibly want it. The level 1 and level 2s, I showed you some of the surface temperature and surface reflectance data. We have our ARD tiled, which is kind of like our level 2s, except it's broken up. And so rather than those slanted scenes that are a little hard to work with, it is a vertical scene with a vertical horizontal coordinate system that's a lot easier to kind of digest. We have level 3 science products. So if you're interested in water, we've got a water product. If you're interested in looking at forest fires, we've got a burned area. If you're interested in snow, we've got a snow product. So all of these things that might not necessarily be traditionally worked with OSM data, just wanted to kind of bring that to the forefront and kind of share that information. And then we also have the surface reflectance-based spectral indices. So this is vegetation, this is snow, this is burn, this is moisture. You can take a look at all of those. So like I said, we already showed the level 2 surface reflectance and surface temperature data. And then on my last slide, I'm actually going to show a NDVI image. But wanted to kind of walk through a couple others as well. So again, this is our ARD tile. Don't know if you can really see that, but we've got the fig ray box that is a full scene. So that's the 180 by 185 kilometers. And then the tile, it's just kind of the bottom right-hand corner that sticks down a little bit. It's a little more color. Don't know how well that's coming across. Our burned area, I'm from Colorado Springs. Took a look at a couple fires that happened in 2012, 2013. You can very clearly pull out where those fire areas were just based on this product. And you can see right here, this was a big fire that happened the year before. This is how it would look natively, but it's just a pixel value that you can pull out and again, overlay OpenStreetMap data to be able to take a look and go, how is it recovering? How are things growing? Also wanted to take a look at the snow product. Again, Colorado Springs, that's where I know, that's what I'm familiar with. Lucky enough, I was able to pull a picture right after a snowstorm, similar to the burned area product. You can take a look, and this is the natural color image in the background. And this red is specific snow pixels that we were able to pull out, but natively it would look like this picture off to the side here. So for those of you who are interested, we've got quite a few different ways to access the data. So whether it's just visualizing it, a great option is our Landsat Look. It offers pulling data from the cloud, so you don't have to download it at all. You can zoom in on an area and take a look at that image that's natively there. One of our most popular Earth Explorer, I'm sure many of you are familiar with, that's kind of our powerhouse. If you're downloading one or two areas, that's a great place to start. But we go down through all the way to like our machine-to-machine API. If you're looking for programmatically get data, that is a great way to do it. You plug in your search criteria, you take a look and say, hey, this is the kind of things I'm looking for. This product, this date range, this area, and hit send, and it goes right to where you pointed it to, and it downloads it so you can upload that folder to work with any other data you might want to. Because that last slide had a bunch of text, I included links here. So if you're interested, take a picture. That's kind of why I put it here rather than cramming everything into one space. One of our most recent developments is actually our Landsat Commercial Cloud. We are hosting our data, any data, Landsat data collection through a AWS server. So if you don't want to look at the full scene, if you want to look at just a single pixel, you can go to our AWS server and go and just pull that 1 30 by 30 meter pixel. So included at Contact Us, again, my name is Jacob Savoy. I work for USGS Aeros. We have a customer service email. If you've got questions about Landsat, chances are the questions are going to come right to me. So if you have them now, you can ask me. Otherwise, feel free to email. We do have a phone number where people are, during work hours, Central Time, people are manning the phone. So if you've got a question, want to talk to somebody, we can walk you through that. We have a listserv. So if you want to get updates on Landsat, you can do that there. And then we have a website. So any big updates we have, we'll post there.